Hello and welcome back to my channel HIL tutorial. Today in this video I am going to discuss about grid forming inverter. Grid forming inverter is very important if you are working in microgrid application, especially in AC microgrid application. So in this video I will tell you how to simulate a grid forming inverter. So step by step, in different step I will simulate it. Okay, so watch carefully this video, and if possible then please support my channel. So let's start. So at first I will take one power GUI. Okay, so from the library take power GUI, double click on it and make it discrete. Okay, and here take 10 e power minus 6. Okay, sample time. Now go to modeling, and inside there is model setting. So click on that and click here this solver selection type, choose fixed step. Then here solver take ODE 4, that is Range Kutta method, and take this solver step size 1 e power minus 6. Okay, now apply and click OK. So solver setting is ready. So at first we will create the plant portion of the grid forming inverter. Okay, then in the later stage we will create the controller for grid forming inverter. So grid forming inverter means it should have a energy storage system. Okay, that could be battery, or there could be an energy system which will be quite stable. Okay, so here for the simplicity I'm going to take a DC voltage source. Okay, so take DC voltage source from the library and double click on it and make it 800. Okay, so this is 800. You can name this one as VDC. Okay, this is the VDC. So now we have one electrical source, right, in DC form. So now we want to convert it into AC because our grid already present in AC, right? So we will require one inverter. So just search for universal bridge. Okay, so take universal bridge from the library. Let's flip it and make the connection like this. Okay, so double click on it because this is universal bridge, and here we can have different types of power electronic devices. So for the inverter we always choose IGBT MOSFET based. Okay, so choose here IGBT diode based power electronics converters, and no need to do anything here, just simply apply. Okay, now we have to measure the output voltage of the inverter. So we will require VI measurement. So simply search VI measurement. Okay, and take it. Now connect it. And double click on it. Here we want to measure phase to ground voltage. Okay, and also we want to measure current here. So now label we will use here. So this will be B1. Okay, and current label also we want to use here. So this is also IABC B1. Simply click OK and rename this one as B1. Okay, now we have to give some filter, okay, because this inverter will generate only square wave. Okay, always keep it in your mind that inverter produce square wave at its output terminal. Okay, so to make it completely alternating in nature, means pure sine wave or approximate to sine wave, we require filter. Okay, so here we will design a filter. Okay, that is LCL filter I will design. So already in my previous video I told you how to parameterize the LCL filters or LC filters. So if you have not seen that videos, please go there and try to watch and understand that videos. Okay, so here I will not going to tell you how to design LCL filter. Better I will simply put the values, okay, which I have designed for 100 kVA inverter and 230 volt phase voltage, okay, and 50 hertz grid voltage. So now we will take one subsystem. Okay, so search for subsystem, go inside this and delete this one. Okay, search for connection port. Okay, this connection port, and copy and paste it one more time, flip it, and you can have like this. So here it is A, okay, rename as A, and this one as small a. Okay, now copy and paste this one 2 times, so it will become B phase. This one will be small b. Again paste it. Okay, so it will become C phase. Okay, now our purpose is to make a LCL filter. Okay, so we will take series RLC branch. Okay, so take a series RLC branch, double click on it and make it RL. Take here 0.2 ohm resistance and 500 e power minus 6 inductance. Okay, copy it and paste 2 more time and ensure the connection. Okay, so these are the grid side. Okay, sorry, inverter side inductance. Similarly, copy and paste it here. Okay, and this will become grid side inductance. Okay, now LCL filter means we have to give capacitor also, so just copy it and paste here, rotate like this and double click on it, make it RC. Okay, and here it will be 100 e power minus 6. Copy it and paste it 2 times. Rename this one as C. Okay, CF. CF. This one also CF. Okay, now connect it. This should be shorted. Now make this connection. It's not like this. It should be connected here, then here, and this one here. Okay. Now this voltage will be important for creating the grid forming inverter. So here we have to measure the voltage. Okay, so here I will take one VI measurement. Okay, so this one should be face to face, and here only voltage I want to measure. So B2. Okay, and current measurement no need, so just click OK and rename this one as B2. Okay, now rotate it, flip it, and do the connection like this. So again we have to connect it. So this will be connected here, this one here, and this one here. So now make connection this side. Okay, so from here what we will get, this face to face voltage we will get. Now our LCL filter is ready. Okay, but here you can see how it is. So let arrange this one. So here it should be right side. Okay, and apply OK. This one also right side. Okay, this one also should appear in right side. So now go back, you can see, make the connection. Okay, now this side also we will require one bus, okay, to measure the voltage and current. And this one we have to rename here like this. This should be B3, and here also this one B3, but this should be face to face voltage and current. Okay, sorry, only voltage. Now we will make this one B3. Okay, now we will connect one load. Okay, so simply search for load, that is series RLC 3-phase load. Okay, so this load will require, double click on it, make it here 400 or 230 star SQRT of 3. Okay, this one 50 Hz, and I will make 0 this one also 0. So only active power we are considering here. So simply click apply and click OK, make the connection. So now the plant is ready. Before that, here I should write this one LCL filter. Okay, so we will everything is ready for the plant part of the grid forming inverter. Okay, so here is the grid forming inverter, and this is the load. Okay, so here is the energy storage system or constant DC voltage supply. You can get it from anywhere, renewable energy sources or any sources you can use. Okay, for simplicity I am taking here constant. So from this inverter will work in such a way that here it will create one grid, means it will supply constant voltage as well as constant frequency. Okay, so that this local load can be power up. So this is the idea behind grid forming inverter. Okay, so let's see next how we will design the a controller for the grid forming inverter. So please watch second part of this video. Thank you.